Before all theories were published by scientists, we only know that acid is sour and base is bitter. Today, we will learn acids and bases, but with a different and deeper meaning. Let's start with the first theory.
Svan de Arrhenius was the first one to propose the theory on acids and bases. His definition of an acid is any substance that contains hydrogen and produces H+ in aqueous solution. For example, a dissociation reaction of hydrochloric acid, HCl. The HCl dissociates into two ions, which are the H+ ion and the Cl- ion. Because this dissociation produced the H+ ion in the solution, by definition, we can conclude that HCl or hydrochloric acid is an Arrhenius acid. Let's go to another example, HBr. HBr dissociates into two ions, which are the H+ ion and the Br- ion. Because this dissociation produced the H+ ion in the solution, then we can conclude that HBr is indeed another Arrhenius acid. On the other hand, his definition of a base is any substance that contains the hydroxyl group and produces hydroxide ions OH- in aqueous solution. Let's consider the dissociation reaction of lithium hydroxide, LiOH, in water. Lithium hydroxide completely dissociates in water and formed the Li+ ion and the OH- ion. Since the dissociation produced the OH ion in the solution, we can conclude that lithium hydroxide is an Arrhenius base. Let's go to another example, sodium hydroxide or NaOH. NaOH completely dissociates in water and formed the Na+ ion and the OH- ion. Since the dissociation produced the OH- ion in the solution, then we can conclude that sodium hydroxide is an Arrhenius base. Arrhenius also described that the H+ ions in aqueous solution are free and floating, but they are actually reacting to water and become hydrated. This forms the hydronium ion H3O+. The reaction of the H+ with water can be written as H+ plus H2O or water to H3O+ or the hydronium ion. In most times, the concentration of H+ and the hydronium ion can be interchangeable. For example, HCl, H+, Cl-. HCl plus water is equal to H3O plus Cl-. Limitations were defined when the Arrhenius theory of acids and bases came out, but later on it was used in the formulation of the more general theories of acid-base behavior. For example, J. N. Bronsted and T. M. Lowry proposed a theory that would remove these limitations. According to the Bronsted-Lowry theory, acid is a proton or H+ donor and it must contain H in its formula. For example, in the reaction of nitric acid, HNO3 with water, it produces the hydronium ion plus NO3 negative. We can see that nitric acid or HNO3 donates a proton to water, hence it is a Bronsted-Lowry acid. On the other hand, the Bronsted-Lowry theory defined base as a proton acceptor, and it must contain at least one lone pair of electrons to form a bond with a proton. Using the same example of the reaction of nitric acid and water, we can see that water accepts the proton from HNO3 and forms H3O+, so water acts as a Bronsted-Lowry base. Let's give you another example. Ammonia, or NH3, plus water, H2O, produces ammonium, NH4+, plus OH negative, or hydroxide. Since ammonia accepts a proton from water, then it is considered a Bronsted-Lowry base. On the other hand, since water donates a proton to ammonia, then it is considered a Bronsted-Lowry acid. Conjugate acid-base pairs are two different species that differ by a proton. In Bronsted-Lowry terminology, every acid has a conjugate base and every base has a conjugate acid. Using the same example of the reaction of nitric acid and water, we told a while ago that nitric acid is the acid while water is the base. Hence, the hydronium ion or H3O+ is the conjugate acid of water, while NO3 negative is the conjugate base of the acid HNO3. In the second example given, ammonia serves as the base while water, which is amphoteric, serves as the acid. OH negative is the conjugate base of the acid water, while NH4+ or ammonium is the conjugate acid of the base NH3 or ammonium. The final theory of acids and bases was proposed by G. N. Lewis, who also contributed to the understanding of the valence electron pairs in bonding. In the Lewis theory, acid is any substance that accepts an electron pair to form a bond. On the other hand, Lewis defined base as any substance that can donate or share one or more lone pairs of electrons to form a bond. The product of a Lewis acid-base reaction is called an adduct, a single substance that contains the new covalent bond. For example, the reaction between boron trifluoride or BF3 and ammonia NH3. The reaction produces an adduct F3B-NH3. Since BF3 have a vacant orbital to accept a lone pair to form a bond, then BF3 is considered a Lewis acid. On the other hand, since ammonia have a lone pair of electrons to donate or to share, hence, it is considered a Lewis base.
We can table all the topics to summarize what we have learned. First, Arrhenius acid produces H+. Arrhenius base produces hydroxide ion or OH negative. Second, Bronsted-Lowry acid is a proton donor, while Bronsted-Lowry base is a proton acceptor. Lastly, Lewis acid accepts electron pair, and Lewis base shares or donates electron pair.